let's go to quadrant 1 and let's focus on this curve here. And let's say that the equation for that curve is like 1/2 x squared plus 7. Doesn't really matter. You guys can just watch if you want. And here's what we want. Let's go to like 2, let's say from 2 to like, let's say 5. And what we want, if we go up, up, up like that, from 2 to 5, underneath the shape, we have this region, this little pocket. And what we want is the area of this. We want the area. The question is, how do I find that area? It's a weird shape with a twist. Like, if it's a circle or a square or a triangle or a rectangle, I know the areas of these basic shapes. What the heck is this, though? This is weird. I've never seen this shape before. So here's a general approach. To find the area of something like that, what we can do is we can split it into sections. And then each section could become a rectangle. And then you have 1, 2, 3, 4, 5 rectangles. And we use rectangles because for the area of a rectangle, it's just base times height. And you could go base times height for all 5 rectangles, add them together, and that gives you an approximate area. It's not perfect, it's not exact, it's just approximate. That's the whole philosophy here. Let's say that we wanted to use 6 rectangles. So from here to here, let's break this up into 6 sections. Here we have 6 regions, but we have to draw the rectangles. So for that, I have a question for you. Should I go purple or should I go green? You see that? Because the purple and the green, they could each represent the height of this last rectangle. So how do I know which one it is? Well, the directions have to tell you. So in the directions, let's say that they say left endpoint. So that means that in your rectangle, in your region, go to the left and you draw your rooftop from the left, right? Go to the next one, draw from the left. Go to the next one, from the left. Let's try that one again. Like that, like this, and then like that. That's what it's going to look like for left. Just to give you an idea, if you just watch, here in orange, if it was a right endpoint, then the rooftops would have looked like this, like that, like that, like that. You see how it could totally differ. So in the directions, they have to tell you if it's left or if it's right. But for the sake of this video, let's just use the left endpoints. And just go like that. So now let's worry about the first rectangle. It's base times height. So the question is, how much is the base? So notice that all the rectangles have the same width. And to find that, you have to go this minus this divided by the number of rectangles. So the width is going to equal 5 minus 2 over 6, which is 3/6, which is 1/2 or 0.5. So we know that each of these rectangles has a width or a base of 0.5. And that makes sense because if I label 2.5, 3, 3.54, 4.5, and then 5, makes perfect sense. So for the area of the first rectangle, let's go base times height. And that's going to be the base is 1/2. Now for the height of the first rectangle, notice it's as tall as the y coordinate of this point. So I have to take 2 and plug it into the equation to get the height of the first rectangle. So that would say f of 2. What about the next rectangle? So this one's done. The next rectangle, it's going to be the base, which is 1/2. Now for the height, I have to go f of 2.5. And I think you see how this is going to go. For all 6 of these, it's going to be 1/2 times f of a number, right? F of some number. It just depends on what it is. Where the last rectangle, this one here in the back, that base times height would be 1/2. And the height would be f of 4.5. And then you add up all of these numbers together, and that gives you the approximate area. However, notice that all of these rectangles, they have the same 1/2 in common. So what we do is we can factor out the 1/2 so that it's 1/2. And then in here, you go f of plus f of plus dot, 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 f of. So the approximate area would be 1/2 times f of this plus f of this plus f of, you add up all the heights together. And in the notes, you have some formulas where instead of 1/2, it's delta x. Delta x is the width of a rectangle. And then inside, instead of going f of plus f of plus f of, we use the Greek symbol sigma, because sigma just represents adding together a bunch of things. So in your notes from your neighbor, you should copy down the two formulas. The formula for the left endpoint and the formula for the right. So if you don't have it, jot it down now. I'll just jot it down real quickly. It looks like this. So for the left endpoint, you go delta x times the summation. And then it says f of a plus delta x times n minus 1. And then for the right endpoint, it's just going to be n. And let me tell you what delta x represents. So delta x represents b minus a over k, where a is the beginning number, and then the last number is b. And then k represents the number of rectangles that are being used. So for instance, in the notes, if they say L100, then they want you to use left endpoints where 100 is k, the number of rectangles used. And an A is always where it starts. And an N is just leave N as N. It's part of the index. And use Desmos to find these things for you. So these are the two formulas. So on Desmos, what should you type in? In Desmos, in box number 1, you should type in f of x equals the actual equation that's given to you. And then in box 2, you should type in the formula. And that's really all you have to do. And then down here, you'll notice there will be a number, and that number equals the approximate area. So just make sure you copy the notes from a neighbor, and then let me know during class if you have any questions.